Hello friend, today I will tell you 8085 microprocessor program to find largest oblique smallest number in array. Structure of program: we assume array size means number of data in array is n, which store at 2500 memory and array start from 2501 memory. If number of data in array is n, then we store largest oblique smallest number which we want to find in array at 250n plus 1 memory. Example: find largest number in array. Here we assume array size is 05 and data in array is 0a to 89. Here you can see largest number in array is DE, so we will store DE at 2506 memory, which is actually next memory after array. To start program, we first initialize memory 2500 in HL pair, then we store array size as a counter value in any one remaining register. Here remaining register is B, C, D, E. Here I am using register C as a counter. We will find largest number in array using compare instruction. Here you can see if array size is 05, then total comparison done in program is 4, means n minus 1 times comparison will done. So after store array size in register C, we decrement in array size by 1. Then we store first data of array in accumulator, then we compare accumulator data with next memory data. Case 1. If accumulator data larger than memory data, then we will not change accumulator data and we compare accumulator data with next memory data. Case 2. If accumulator data is smaller than memory data, then we will first copy memory data in accumulator and we compare accumulator data to next memory data. In this way, after all comparison, we found largest number in accumulator. So we store largest number from accumulator to next memory after array. Compare 1. Here you can see first data of array is 0a, so we store 0a in accumulator, then we compare accumulator data with next memory data, which is 12, and here 12 is larger, so we will store 12 in accumulator from memory. Compare 2. Now accumulator data is 12 and next memory data is 08, so we compare 12 with 08. Here 12 is larger, which is already in accumulator, so we will not change accumulator data. Compare 3. At this time accumulator data is 12 and next memory data is DE, so we compare 12 with DE. Here DE is larger, so we will store DE in accumulator from memory. Compare 4. Now accumulator data is DE and next memory data is 89, so we compare DE with 89. Here DE is larger, which is already in accumulator, so we will not change accumulator data. In this way, we found largest number in accumulator. Note: microprocessor perform comparison as A minus M oblique R oblique data, and after comparison, accumulator data and M oblique R oblique data content not change. Only flag register status change according to compare instruction. Case 1. If accumulator data is greater than M oblique R oblique data, at this condition carry flag and 0 flag both are 0, means reset. Case 2. If accumulator data is less than M oblique R oblique data, at this condition carry flag is 1, means set, and 0 flag is 0, means reset. Case 3. If accumulator data is equal to M oblique R oblique data, at this condition carry flag is 0, means reset, and 0 flag is 1, means set. Example of comparison. Compare M is example of compare accumulated data with memory data. Compare B is example of compare accumulated data with registered data. Compare 5-8 example of compare accumulated data with 8-bit data. Algorithm of program: initialize the memory location in HL register pair, move array size in register C to define counter, decrement the counter, increment the memory pointer, get first data of array in accumulator, increment the memory pointer, compare accumulated data with memory data. If no carry, go to step 9. But if carry, move memory data in accumulator, decrement the counter. Here register C work as a counter. So after decrement, if register C data is not 0, at this condition 0 flag is reset means 0, and if register C data is 0, at this condition 0 flag is set means 1. So if 0 flag is 0, go to step 6 means we will perform one more comparison, or if 0 flag is 1, go to next step which is result store step. Increment the memory pointer, store largest data in memory, terminate the program. Flowchart of program: start, then initialize memory in HL pair. By this step, we store memory address in HL pair, then get counter value in register C. By this step, array size copy in register C, then decrement in counter value. By this step, we get actual counter value which is equal to total number of comparison. Then increment memory pointer. By this step, we pointing first data of array, then get first data in accumulator. By this step, we copy first data of array in accumulator, then increment memory pointer. By this step, we pointing next data of array is M, then compare accumulator data with memory data. By this step, comparison perform between accumulator data and memory data. Then if carry, there is two condition: carry generate or carry not generate. If yes condition means memory data is larger, so first we copy memory data in accumulator. By this step, we copy larger data in accumulator. If no condition means accumulator data already is larger, so we not replace accumulator data, we skip this step, we directly execute this step which is decrement in counter value. Because we have done one comparison, so we decrement counter value by 1, then we check counter value. If 0, there is two condition: counter value 0 or counter value not 0. If no condition means we have not compare all data, so we go to perform next comparison between accumulator data with next memory data, and to get next memory data, we increment memory pointer. If yes condition means we have done all comparison and largest number have in accumulator, now we store largest data in memory. So increment memory pointer. By this step, we increment HL pair memory address by 1 for store largest number in memory. Then copy largest data in memory. By this step, we store largest data from accumulator to memory, then stop program. Now first of all, store inputs data in memory. We store array size 058250 memory. Then we store array data from 2501 to 2505 memory. Now we feed program. Starting address of program 2000 and first instruction is LXI H, 2500. Store 2500 16-bit data address in HL register pair for initializing input address. 21 is hex code of the instruction, 00 is lower byte of address, and 25 is higher byte of address. By this instruction 2500 store in HL pair. Then next instruction is move C, M. Copy array size in register C. 4E is hex code of the instruction. By this instruction HL pair have 2500, so 05 copy in register C from 2500 memory. Then next instruction is DCRC. Decrement in register C data by 1. 0D is hex code of the instruction. By this instruction register C data become 04, which is actual counter value. Then next instruction is INXH. Increment HL register pair data by 1 to point next memory data. 23 is hex code of the instruction. By this instruction data address in HL pair become 2501. Then next instruction is move A, M. Copy first data in accumulator from memory. 7E is hex code of the instruction. By this instruction HL pair have 2501, so first data 0A copy in accumulator from 2501 memory. Then next instruction is INXH. Increment HL register pair data by 1 to point next data is M. 23 is hex code of the instruction. By this instruction data address in HL pair become 2502. Then next instruction is CMPM. Compare accumulator data with memory data. BE is hex code of the instruction. By this instruction microprocessor compare accumulator data 0A with memory data 12 and carry flag bit become 1, which show memory data is larger. Then next instruction is JNC down. Jump to down if no carry. D2 is hex code of the instruction. Here you can see down level of address is 200D. So first 0D lower byte of address has come, then 20 higher byte of address has come. But now at this stage carry is 1, so microprocessor not jump to down level. So next instruction is move A, M. Copy memory data in accumulator. 7E is hex code of the instruction. By this instruction HL pair have 2502. So larger data 12 copy in accumulator from 2502 memory. Then next instruction is DCRC. Decrement in register C data by 1. 0D is hex code of the instruction. By this instruction register C data become 03 and 0 flag bit is 0, means comparison is remaining in program. Then next instruction is J and Z up. Jump to up if register C data is not 0. C2 is hex code of the instruction. Here you can see address of up level is 2007. So first 07 lower byte of address has come, then 20 higher byte of address has come. But now at this stage register C data is not 0. So microprocessor jump to up level and the instruction at up level is INXH. Now instruction repeat in program, so I directly explain you next process. So by INXH instruction data address in HL pair become 2503. Then next instruction is CMPM. Now microprocessor compare accumulator data 12 with memory data 08 and carry flag bit become 0, means accumulator data is larger. Next instruction is JNC down. Now at this stage carry is 0, means no carry, so microprocessor jump to down level. and we know down level address is DCRC. By this instruction, register C data becomes 02 and 0 flag bit is 0. Next instruction is J and Z up. Now at this stage, register C data is not 0, so microprocessor jump to up level. And next instruction of up level INX edge. By this instruction, data address in HL pair becomes 2504. Then next instruction is CMPM. Now microprocessor compare accumulated data 12 with memory data DE and carry flag bit become 1, means memory data is larger. Next instruction is JNC down. Now at this stage carry is 1, so microprocessor not jump to down level. Next instruction is move A, M. By this instruction, HL pair have 2504, so larger data DE copy in accumulator from 2504 memory. Then next instruction is DCRC. By this instruction, register C data becomes 01 and 0 flag bit is 0. Next instruction is J and Z up. Now at this stage, register C data is not 0, so microprocessor jump to up level, and the instruction at up level is INXH. By this instruction, data address in HL pair become 2505. Then next instruction is CMPM. Now microprocessor compare accumulated data DE with memory data 89 and carry flag bit become 0, means accumulated data is larger. Next instruction is JNC down. Now at this stage carry is 0, means no carry, so microprocessor jump to down level, and next instruction is DCRC. By this instruction, register C data become 00 and 0 flag bit become 1, means all comparison has been done. Next instruction is J and Z up. Now at this stage, register C data becomes 00, so microprocessor not jump to up level. Now we store largest number of array in memory, so next instruction is INX edge. Increment HL register pair data by 1 to store largest data in memory. 23 is hex code of the instruction. By this instruction, HL pair data become 2506. Then next instruction is move M, A. Copy largest data from accumulator to memory. 77 is hex code of the instruction. Now you can see HL pair have 2506. So largest data DE copy from accumulator to 2506 memory. Then RST5 and program. Find smallest number in array. There is one change in algorithm of program. Compare accumulator data with memory data. In this program, if carry, we go to step 9. And in flowchart of program, if carry, if no condition, we copy data in accumulator from memory, means we copy smaller data in accumulator. If yes condition, means accumulator data already smaller, so we skip this step. And in program, there is one change. We use JC down instruction instead of JNC down. Jump to down if carry. DA is hex code of the instruction. Now we perform practical on kids. So we feed input. We set examine memory, input address 2500, then next 05 array size, then next first data 0A, then next second data 12, then next third data 08, then next fourth data DE, then next fifth data 89, then next. Now we feed program. Starting address of program 2000. So reset examine memory 2000, then next. LXIH hex code 21, then next. 00 lower byte of address, then next. 25 higher byte of address, then next. Move C, M hex code 4E, then next. DCRC hex code 0D, then next. INX H hex code 23, then next. Move A, M hex code 7E, then next. INX H hex code 23, then next. CMPM hex code BE, then next. JNC hex code D2, then next. 0D lower byte of address, then next. 20 higher byte of address, then next. Move A, M hex code 7E, then next. DCRC hex code 0D, then next. JNZ hex code C2, then next. 07 lower byte of address, then next. 20 higher byte of address, then next. INX H hex code 23, then next. Move M, A hex code 77, then next. RST5 hex code EF, then next. Now we execute the program. So dot go, starting address of program 2000, then dot. Now we see the result. So examine memory, output address 2506, then next. Here you can see result DE. Now we execute smallest number in array. So we use JC instruction instead of JNC, and DA is hex code of this. So we go at 2009 and edit hex code. So reset examine memory 2009, then next. Here we edit hex code DA, then we save this for next. Now we execute program. We already feed inputs. So dot go, starting address of program 2000 dot. Now we see the result. So examine memory, output address 2506, then next. Here you can see output 08. If you have any query related any program of microprocessor, write in comments. I will help you. Click to my photo to subscribe my channel. Please share and like my video to get more video. Click to play my other video which show on this screen. Thank you.